Hello, good morning. This is Teacher Annabelle, and welcome to Physics class. Before we begin, I would like to introduce you my friend, Susie. Her mother told her that 2 hours from now, her friend will come and visit their house. But Susie seems to be worried. How can she cook and clean their house in an easier and faster manner? Which of these things can help Susie? Is it a microwave oven, a firewood, a vacuum cleaner, a washing machine, or a paper? Thank you for helping Susie. We all know that microwave oven can help her cook easier. However, vacuum cleaner and washing machine can help her clean the house in an easier and faster manner. Today, we are going to talk about these things. What can help us in making our work easier and faster? But before we begin our lesson, I would like you to prepare the following things: your physics book, a pen, your copybook, and a calculator for some mathematical equations later on. Machines. Today, we're about to continue our lesson about energy. And one concept related to energy is all about machines. I would like you to open up your book on page 155. Our main objectives for today is to define and describe a machine, compare the three types of a lever, and demonstrate understanding on how machines like lever and pulley works in making work easier and faster. Machines. In physics, we know that machine can transfer energy from one place to another or transforms it from one form to another. A machine is a device used to do two things. First, to multiply forces or to simply change the direction of forces. The concept that underlies every machine is the conservation of energy. Remember, a machine cannot put out more energy than it is put into it. It says that a machine can multiply force but never energy. That's because machine underlies on the concept of conservation of energy. That means the energy being used are neither created nor destroyed. A machine can multiply that force, but the energy given or used are not being changed. One example of a machine is a lever. A lever is a simple machine made of a bar that turns about a fixed position. If the heat from friction is small enough to neglect, the work input will be equal to the work output. The word input and output are two words that we're going to focus when we are talking about simple machines. When we are talking about input, it's either the work, force, or energy being exerted to the machine. However, if you are talking to the output, it is either the work, energy, or force being exerted by the machine to a certain object. Since work is equals to the force times distance, we can say force times distance of the input is equals to the product of force and distance of the output. A lever has three parts. First, the effort. It is the place where you can exert your force. Next, the fulcrum. It is a pivot point around which a lever turns. And the last one is where you're going to put the load. The fulcrum of the lever can be relatively close to the load. Remember, when a small input force are exerted through a large distance, it will produce a large output over a short distance. In this way, a lever can multiply forces. However, no machines can multiply work or energy. In the lever, the work done at one end is equal to the work done on the load at the other end. Looking at the picture below, you can observe a fulcrum which is closer to the other end, wherein in a shorter distance, it can create a bigger force. However, on the other side, it can create a smaller force for over longer distance. Even they have difference in forces and distances. If we are able to get the product between force and distance on each side of this lever, they are going to become equal. Look at the example below. The output force is 8 times the input force exerted by the girl. As you can see, when the girl exerted 10 newtons over the machine gives up 18 newtons. It is indeed 8 times stronger. However, even though the girl exerted 10 newtons, she exerted it for a longer distance for 1 meter. However, the machine exerted a greater force of 80 newtons for over 1/8 meters. How can we able to know if they are equal in work? Let us get the product of both sides of the lever. If we are able to multiply 10 times 1, that is equals to 10. 80 times 1/8 is equals to 10. See, the work between the two sides of the lever are equal. Let us see if you are listening. Looking at the problem below, do you think that the work done at one end of this lever is equal to the work done on the load of the other end? How can you say so? Excellent! The answer is yes. If we're able to get the work of both ends of this lever, you can get 300. Good job! So, the ratio of output force to input force of a machine is called mechanical advantage. To get the mechanical advantage, you can divide the output force divided by the input force. So looking at this example, if we are able to divide 30 newtons and 10 newtons, the mechanical advantage is 3. Neglecting friction, the mechanical advantage can also be determined by the ratio of input distance to output distance. So, if we are able to use distance as our basis to get mechanical advantage, We can divide input distance divided by output distance. 30 meters divided by 10 meters is equals to 3. The mechanical advantage is still 3. There are 3 common ways to set up a lever. We have the type 1 or the first class lever, the type 2 or the second class lever, and the type 3 or the third class lever. In order to know the difference between the three, it is the easier for you to understand and remember the center of each machine. Remember, there are 3 parts of the lever: the effort, the fulcrum or 5/0, and the load. In the first class lever, you can observe that the fulcrum can be found in the middle. However, in a second class lever, the load is being put in the middle. In a third class lever, it is the effort which can be found or exerted in the middle of the lever. Again, if first class lever, the middle is fulcrum, and second class lever, the middle is where you're going to put the load. In third class lever, the middle is where you're going to exert the effort. For the type 1 lever, you can push down on one end and you can lift the load on the other end. The best example of the first class lever is a seesaw, where you are playing when you are in the playground. For the type 2 lever or the second class lever, when you lift the end of the lever, the input and output forces are on the same side of the fulcrum. The forces have the same direction. The best example of a type 2 lever is a nutcracker. As you can observe, the load can be put on the middle. In a type 3 lever, you can use a tongue as the best example of it. The input force is applied between the fulcrum and the load. The input and output forces are on the same side of the fulcrum and have the same direction. Another example of a machine is a pulley. A pulley is basically a kind of lever that can be used to change the direction of a force. Properly used, a pulley or system of pulleys can multiply forces. There are 3 things that you should know about pulleys. First, a pulley can change the direction of the force. Giving at the example and the picture below, you can find there that if the boy is exerting a force downward, the load is moving upward. And if the boy is exerting force upward, the load is going downward. A pulley can also multiply force. And if there is 2 pulleys, it can change the direction and multiply the force. This single pulley in the example below behaves like a type 1 lever. The axis of the pulley, which is the circular shape, acts as the fulcrum. Both lever distances are equals, so the pulley does not multiply force. However, it changes the direction of the applied force. The mechanical advantage is equals to 1. How did I get the mechanical advantage? In physics, the mechanical advantage for simple pulleys is the same as the number of strands of rope that actually support the load. In the example below, there is only one strand of rope which supports the load. However, The other rope acts to change the direction of the applied force only. This single pulley in the example below acts as a type 2 lever, where the fulcrum is at the left end of the lever where the supporting rope makes contact with the pulley. We can observe that the load is halfway between the fulcrum and the input. 1 Newton of input will support a 2 Newton load, so the mechanical advantage is 2. The load is now supported by 2 strands of rope supporting half the load. How did we get the 2 or the mechanical advantage of 2? That's because in this example, there are already 2 ropes or strands of ropes which supports the load. In this example, the mechanical advantage of this system is 2. Although the 3 strands of the rope is shown, there are only 2 strands which actually supports the load. The upper pulley and the other strand of the rope serves only to change the direction of the force. Let us take this another example. When the rope is pulled 5 meters with a force of 100 newtons, a 500 newton load is lifted 1 meter. The mechanical advantage is 5. How did they get it? Again, if you can still remember, in order to get the mechanical advantage, we need to divide the output force divided by the input force. 500 newtons divided by 100 newtons is equals to 5. Therefore, the mechanical advantage of this problem shown on your screen is 5. Force is multiplied at the expense of distance. This ends our lesson. Thank you for listening. And do not forget to answer your homework written in your weekly plan. Bye bye.